start recording. And please mute your microphone except when you would like to speak. And if you'd like to speak, raise your hand or unmute and we'll get to you. There's also a chat on Zoom that you can send a message that the host, who is Sherry, happens to be Sherry right now, will be helping with the Zoom. We'd like to start with the invocation. Reverend Dave Thompson, would you please lead us in our invocation, please? Where is he, Dave? Oh, unmute Dave. He's muted.
There we are. Okay. All right, let's be in prayer. Lord, we thank you for beautiful days, and we pray for rain. We thank you for the possibility of vaccines and more health for more people. We pray for those who grieve and for those who are ill. We thank you for being a part of Rotary, which is a part of service to our world, to our community, and to each one of us here. For these blessings, we give you thanks and praise. Amen.
Thank you, Dave. And Jerry, since you have the flag there behind you, would you please lead us in the Pledge of Allegiance?
Sure. If you'll all join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all.
So as your assistant governor for Area 1, I'd like to welcome all of you here attending for this Rotary joint meeting of our second installment of our Rotary Area 1 Speaker Series. Our third installment, which we'll get more information on later, will be hosted by the Rotary Club of Lodi Tokay next month in January. And I will be sending information out on that. And Trip, we could all use a little smile or a chuckle today. Do you have a joke for the day?
I do. I have a little short Christmas joke. All right. So Lee, a 7-year-old boy, was asked to say thanks for the Christmas dinner. The family members bowed their heads in expectation. Lee began his prayer, thanking God for his mommy, daddy, brothers, sister, grandma, and all of his aunts and uncles. Then he began to thank God for the food. He gave thanks for the turkey, the stuffing, the Christmas pudding, even the cranberry sauce. Then Lee paused, and everyone waited. And they waited. After a long silence, the young fellow looked up at his mother and asked, "If I thank God for the Brussels sprouts, won't he know that I'm lying?"
All right. Thank you, Trip. And now for a Rotary moment from Doug Hulk. Doug, are you there?
I'm here, Joe. Just want to be sure to remind everybody that the end of the year is fastly approaching. And so those of you that need massive tax deductions, please remember the Rotary Foundation and just go to rotary.org/donate and pick your favorite aspect of Rotary. Remember, Rotary is where neighbors, friends, and problem solvers share ideas, join leaders, and take action to create lasting change. There's 1.2 million of us in 35,000 clubs. We take action locally and globally each day. Our members pour their passion, integrity, and intelligence into completing projects that have lasting impact. We persevere until we deliver real and lasting solutions. We solve problems. No challenge is too big for us. For more than 110 years, we've bridged cultures, connected continents, and championed peace, fight illiteracy, poverty, promote clean water, sanitation, and fight disease. 2.5 billion children have been immunized against polio as we continue to promote peace, fight disease, provide clean water, save mothers and children, support education, and growing local economies and protecting the environment. So every dollar is put to good use. Thank you for your support.
Thank you, Doug. We've got a number of visiting Rotarians, and we're going to forego individual introductions. However, we should have Rotarians. Is there anyone here from the Galt Morning Club? And we should have visitors from the Lodi Sunrise Club. And Lodi Tokay. Okay. And sitting next to me is a person that's helping with the Zoom, and she happens to be our district governor, Sherry Cotta. Just a quick announcement. There is the Lodi High School Interact Club has a project going on, and Jerry Fry has a little bit to say on that.
Thanks, Joe. Jackie, the advisor for the Lodi High Interact Club, wanted to be here today and watch this, but she couldn't make it. So anyway, they're having the Interact Club and we're just fortunate, in Lodi to have two great Interact clubs and two wonderful advisors, Trip and Jackie. And anyway, Jackie wanted me to let you all know, and I think, Sherry, can you put up that, share the screen with the little flyer there? But anyway, they're having a sock, called a sock drop, and it's for they're collecting socks for the Salvation Army. And if you get a chance, the drop off is today and tomorrow at 4 o'clock this afternoon at Lodi High School, and tomorrow from 2:30 to 3:30 p.m. at Lodi High School. So if you have some new socks that you have hanging around, or get a chance to sneak down to someplace and pick some up, they would certainly appreciate it. And these are going to go to the Salvation Army. So anyway, thank you all for helping out. And as I said, we really appreciate the advisors we have for our Interact clubs in Lodi. So thanks, Joe.
All right, thank you, Jerry. Also, next week will be our Christmas program here on Thursday. So stay tuned for more information on that. Now, I think we can go ahead and introduce our speaker. And it is certainly an honor and a privilege to introduce our distinguished person for our second installment of our Area 1 Speaker Series. Our speaker is a Lodi native, attended Vinewood School and graduated from Lodi High School in 1984 as one of 4 valedictorians. He comes to us from NASA's Jet Propulsion Laboratory in Pasadena, California. There, he leads its Mechanical Systems Division, about 1,000 engineers involved, who design, build, and test robotic spacecraft destined for planets Mars, Jupiter, Venus, and our own Earth. He grew up in Lodi and studied aerospace engineering at USC and the University of Texas. And in his career, he's done engineering for the Space Shuttle, Space Station, and Mars landers rovers. Here for you this afternoon is our speaker, Mark Johnson.
Hello, everybody. Thanks for having me. I'm pleased to be here. And thanks for reaching out. I see Jerry's got the article that was in the paper that I got to be a part of, and it was kind of a fun connection back to Lodi And I'm happy to sort of continue that with this talk. So I do have a slideshow to give and talk a tiny bit about me, mostly about JPL and the work we do there, both historically and work that's going on now, actively going forward. And then I think we have time for questions if there's any questions people have. So if I can get this part to work, let me see if I can do my sharing. Okay, is that working for everybody?
Yes.
Okay. All right. So yes, it's we're talking about space exploration, journey from Lodi to Mars by way of Pasadena and JPL, or the Jet Propulsion Laboratory for NASA. Okay, as for me, I did say there's a little bit about me. Like a lot of people, perhaps, I grew up doing Estes model rockets in parks of Lodi, actually. You know, Vinewood Park, right behind the home where my mom still lives. That's actually my brother, my daughter, my nephew there doing some rockets they built, and some old rockets from when I was the same age as the little boy sitting down there that we managed to keep somewhere in the house for 40, 50 years, you know, somewhere between there, and still got them to fly again. But then more recently, that's me with a big rocket. There's instead of Estes rockets, now we're launching Atlas rockets. And this is an Atlas rocket that took our Mars InSight mission from Earth to Mars. It launched in November of 2017. And launched, I got my dates wrong, landed in May of 2017, landed in November of 2018. Okay, and as that intro said, prior to that, I was very pleased to have a chance to work on what I think are some of space exploration's greatest hits. While I was still in college, I got to work down here in Southern California, where I am now, on the space shuttle Discovery. This was after the Challenger disaster. That happened while I was in college. And I think in an indirect way, that was my springboard and a chance to get into the business, because they needed to do a lot more engineering work. The shuttle was already built and flying by then, of course, when I was in college, but they had to do a lot of analysis, mechanical stress analysis for every flight, even more so after that accident. And I got to work part-time during college and then full-time over summers doing stress analysis on the Space Shuttle Discovery. And I like this picture because the part I got to do, like all of the work I'm describing today, there isn't hardly a single individual effort anywhere. They're all teams, and they're big teams of people. Everyone is part of a big team, and you're doing a small part. And frankly, that doesn't work for everybody. I know I've worked with a number of people who do this business for a little while, and they spin off and go do something entrepreneurial or in a small company because they want to have a bigger individual impact. But when you're doing things like a space shuttle, it doesn't work that way. Everyone does a small part, and you have to be the kind of person who gets satisfaction out of being doing your part of the widget. You're doing your widget successfully that makes the whole thing work. So my part of the widget was in what they call the mid-fuselage, or the cargo bay of the space shuttle. There were structural members, frames and ribs that it needed structural analysis, and that's what I got to do. As a college student, I was thrilled to do so. Then after I graduated from University of Texas, I came back to California and got to work right away on the International Space Station. That was a real thrill. If it's still flying, of course, right now. It's above us as we speak. And you can see from the picture, those giant kind of amber colored things, those are solar panels. Each one is about the size of a football field. And we had all those to build. And I was part of the team that was working on those football field sized deployable sort of fan folded solar panels. And that's where I got to start to move into kind of a specialty, which was mechanisms. So, gearing and motors and ball bearings and things like that to go into devices that happen on the space station. That was also my opportunity to do my only work really with astronauts, because although it was motorized deployments, those mechanisms I talked about, there was both some deployments that required astronauts to get out there in suits and unfold things, and there were astronaut backup systems for everything, so that if things didn't work right, The astronauts would get out there with their version of kind of a Makita cordless drill and operate the things in case our motors broke down. And then most recently, like the rocket I showed in the earlier slide, I got to work on the Mars InSight lander, where I was doing a little different type of engineering, systems engineering, for the entire vehicle that was landing on Mars, and doing seismic research, trying to find out the nature of the crust and core of Mars. Okay, so I mentioned JPL a little bit. That's almost all my careers at JPL. The Space Shuttle and Station, earlier stuff, those were other places, but ever since 1998, I've been at JPL, which is the Jet Propulsion Laboratory. It's down in Pasadena, California, and it's part of NASA, as you see there. But you also see California Institute of Technology, and that's because JPL is not part of the federal government. We aren't federal employees. We're not government employees. We're Caltech employees. That's a unique arrangement that happens in a few places. They're called FFRDCs, Federally Funded Research and Development Centers. NASA has one of those. That's JPL. NASA has a lot of other NASA centers. There's one in the Bay Area in California, NASA Ames Research Center. And of course, everyone knows about Johnson, right? Johnson Space Center, the astronauts talk to. And there's ones in Florida, of course, for launch complexes. And really, there's about 7 all told. Okay, but JPL, we're part of Caltech, and we're down there in Pasadena. Now, JPL's history is long, and it actually predates NASA. In the beginning, in the 1930s, there were researchers at Caltech who wanted to do rocket research, or at least rocket engine research. Back when that sounded like, I don't know what the equivalent would be today, because it sounded silly. It sounded like comic book science. It didn't sound like anything real that anyone would take very seriously. So they had trouble getting going, but they eventually did get going on campus. And but they quickly moved off campus because they had a tendency for things to blow up. It's just the nature of rocket research. So this is a famous photo for people at JPL. It's sometimes called our nativity scene. And this is some of the early the Suicide Squad guys out there in the, if you've been to Pasadena, you know we're at the foothills of the San Gabriel Mountains. So their academic advisor, I think, told them, why don't you guys go up into the foothills? That way, if you blow something up, you'll maybe only blow yourselves up. You won't blow up our building or anything. So they went out to the Arroyo. They've got a fuel line there. It's hard to see, but there's a little rocket engine pointing up as they're trying to do some thrust research on here, doing early stuff in the 1930s. Pretty soon they got some some Army contracts, which was great for them. And the first application was putting rockets on airplanes for assisted takeoff. It was called RADO or JADO for rockets that were on airplanes. And that was a contract they got going. Then they got going into some bigger rockets. And this was started during World War II. It actually went after World War II when they were starting to do some of these flights. These guys were heavily motivated to defeat fascism. That's what they were doing. They thought they wanted, they were trying to do their part to win the war against fascism. And at the time, that's what rockets looked at, but also sounding rockets for scientific research. So when there was a chance after the war to pivot into purely scientific work, that's what we did. That's about the same time NASA was formed. America's first satellite after Sputnik was called Explorer 1. There's 3 guys holding it up above their heads, a model of it, after it successfully flew. The fellow on the left with the tie clip, you can see that's our first, not our first, but that was our JPL director at the time that we launched Explorer 1, 1958, a year after Sputnik, and NASA was formed with JPL as one of its very starting members. If you go to JPL today, and other than COVID conditions, you can. So you can't go today because of COVID. We're largely working from home. That's where I am right now. But once a year, we do have an open house, and we'll get back to that soon enough. And if you come to Southern California, you can check it out. This is where we are right now. You can kind of tell this is literally the same area. Those guys that were, trying to not blow up buildings, so they went out to the canyon. This is where it is. Now, of course, there are a lot of buildings. Those are all of our buildings, as you see in the photos, but there's actually neighborhoods around too. And there's off to the left here is a riding club with horses and things like that. And a county park down here. But it was originally pretty desolate, and we have been out there for all those years since then. We've got a great website. If you go to jpl.nasa.gov, You can see all kinds of things. That's where a lot of the photos I'll be showing you today came from. Okay, so NASA does a lot of things. I mentioned Johnson before, I mentioned astronauts before, but that's not what JPL does. JPL very quickly became the center that focuses on robotic space exploration of the solar system. And that started right off the chute with the Ranger program. This was in the days of the Apollo, the space race with the Soviets back then. And one of the first things we needed to do was figure out even how to fly to the moon without an astronaut on board, without the danger of killing an astronaut. So we not only flew to the moon, but crashed into the surface with a camera taking pictures all the way down. So we had a bunch of struggles in the beginning, but then a bunch of successes flying those missions. That led to the Mariner program, where we're flying out to other planets. We do flybys of Jupiter and Venus and even Mercury, and eventually orbiters of those things too. And also learning to fly by other planets. You may have heard how we can sort of give ourselves a little slingshot maneuver by dipping close to a planet, letting its gravity pull us in, and then zipping out the other side. That enabled a very famous mission for us called the Voyager mission. The Voyager mission was the first one to the outer solar system, moved beyond Mars, beyond the asteroid belt, out to Jupiter and Saturn. And one of the Voyagers, there were two, one of the Voyagers even went to Uranus and Neptune as well. And they're still flying. They're beyond our solar system. They're beyond Pluto's orbit. They're actually cruising along in interstellar space right now, getting by in a trickle of power and communication back to us, telling us it's the only thing that man has ever built that is moving beyond the solar system, man-made object. Not long after that, we got into the business of going to planets and orbiting them more long-term. So Magellan was a mission to orbit Venus and look through its incredibly thick clouds with a radar system, not a camera system, to find out what was under the surface on Venus. Galileo was an orbiter that went back to Jupiter. I mean, we'd gone by Jupiter with Voyager, but now we're going to orbit Jupiter. Jupiter is, of course, the biggest planet in the solar system, but it's complicated in a lot of ways because it's almost like a mini sun. It's almost like a mini sun that didn't quite turn on yet, but it doesn't glow or shine like the sun, but it emits a ton of radiation, and it's a really difficult place to visit for that reason. It fries electronics, it crisps up plastics, it does all sorts of terrible things that are tough on robots. So that was the Galileo mission. And then we went back to Saturn with the Cassini mission. And from Galileo and Cassini, going to Jupiter and Saturn, besides the massive planet themselves, those places have lots of moons. And we, although we're orbiting the main planet, our navigators at JPL would do little thruster rockets here and there to adjust the orbits and then design them so that we would swing by various moons and take a close look at them whenever we could do that as well. But if you know anything about JPL, you know about Mars, and you're wondering why I haven't said more about Mars, because we have been especially going to Mars, starting with Viking in the 70s program, both an orbiter and a lander. And then more recently, we've had this entire campaign for about the last 25 years of going to Mars over and over again, and we're in the news a lot for that. Mars Reconnaissance Orbiter is something that put kind of like, if you want to think of it as a SpySat camera, I'm sure it's not as good as the SpySats. We don't do military classified work really at JPL, but that's how we use it as shorthand, is let's put a super duper camera on an orbiter to help us figure out safer places to land or where we want to land for scientific reasons. And that, of course, has led to a series of rovers that people know about JPL. We're the ones that are doing those rovers on JPL. Started with this little Sojourner rover back in 1997. It landed about the size of a microwave oven and just drove within visual range, but it was disconnected from the parent spacecraft. It really was an independent little spacecraft of its own. Then Spirit and Opportunity, maybe about the size, they say, of a Galapagos tortoise, although you can see the guy standing here in our test field, so you can tell the scale of them yourselves. And then Curiosity, the one that's still cruising around right now. Opportunity finally died not too long ago, a couple of years ago, but Curiosity is still going along, and then you see it's a lot bigger. Actually, all of these rovers have had some little robotic arm or thingy on the front of them. It was very tiny on Sojourner, you didn't hardly see it. I don't know if you can see this middle tube here. There was a small robotic arm on Opportunity and Spirit, but there's a big prominent arm with a lot of stuff on the end of it on Curiosity. And that's what we're going to do scientific. Well, we're trying to be like a field geologist or field chemist on the surface of another planet, doing it with a robot. And then you see these periscope devices for cameras and other instruments on top. Okay, we'd gotten so good at exploring other planets somewhere along the way, actually in the 70s, it was fairly early on, we figured out we needed to do that same sort of rigor and shine the light back on our own Earth. And we started moving into the Earth observing world, especially radar. I mean, we humans see more in visual images, you know, cameras and things like that, but radars can do all sorts of other sort of imagery and other sorts of looking at the Earth, remote sensing we call it, and do all sorts of things. So CSAT happened in the early 70s, proved that concept was viable, and then we did a lot more. There was the SRTM, Shuttle Radar Topography Mission, where the things that we're all used to now, like, you know, Google Maps. Well, I think Google Maps largely comes from airborne. So we have, you know, when you zoom in and look at the swimming pool in your neighbor's backyard, you know, that's aerial. But behind it, underneath it, is a mapping of the entire world and its elevation topography that came from JPL mission SRTM in the, when was that? Just right around the turn of the century, right around 2000, where we orbited the entire Earth. And we had the main antenna inside that shuttle cargo bay, and then a secondary antenna that was important for triangulation to measure height of the Earth out on this giant boom. And then more recently, like completely contemporary now, we have a lot of missions that are looking at Earth's climate. The Orbiting Carbon Observatory, CloudSat with its cloud penetrating radar, and Aquarius, which looked at a lot of surface water measurements. That one was done in a partnership with the Argentines. That's why we've got that picture showing it flying over Argentina. A lot of people wouldn't even think that Argentina has a space program, and it's not big like ours, but yeah, they have a space program. And in fact, we, JPL, built the instrument. They, the Argentines, built the rest of the spacecraft. And they looked for an opportunity to partner with NASA to do that mission. And in fact, that's also a feature of the modern space exploration. It's a lot more international than it ever was. It was a little international in the old days, and we had some real notable first competition with the Soviets, then some partnership. We did a lot more on the International Space Station. It's got it right in the name, but more and more now, as the Cold War is kind of behind us, we're doing a lot more in partnership, basically because space is hard and space is expensive. So if we can split the cost with someone, we do the instrument, you do the spacecraft, or we'll do this, but you provide the launch vehicle, the rocket, something like that. That helps everyone's dollar or euro or yen stretch a little further. Now, let me just hit some missions that we're doing at JPL right now, some of which you may have heard about, some may be surprising. I just mentioned international partnerships, and here's another one. It doesn't have a catchy name. It's called NISAR, but that stands for NASA ISRO Synthetic Aperture Radar. So it's another of those radar missions that can do, depending on what they're doing, the frequency of the radar, they can be looking for water, they can be looking for subsurface water, they can be looking for different chemicals in the atmosphere, they can do all sorts of things. And ISRO is the Indian Space Agency over in India. So here again, we're doing the instrument, the big deployable antenna, which has a bunch of radar antennas in radar instruments inside here, but the parent spacecraft, if you want to call it that, this box back here and the solar panels and the communications to the ground, that's being done by the Indian Space Agency. And we're working with them on that. Likewise, one called SWAT. This is a surface, water, and ocean topography. This is a partnership with the French. And actually, we have a very long history partnering with the French on this particular kind of research. I'm not sure why that started that way, but we have decades of partnership with the French doing space-based water research, trying to understand the water cycle, where it's going, elevation of lakes, surface winds across the ocean, all trying to do more and more climate research, which is important for living on our Earth and not screwing it up. Okay, But Mars is still front page news, right? That's our banner thing. So we have, you saw the Curiosity rover before. We right now have Halfway to Mars, another rover. This one's called, I don't know if anyone knows what it's called. It's Perseverance. Perseverance is on the way right now. It looks a lot like Curiosity. It has that jetpack landing system like is shown there. It lands directly on its wheels. It's the same size as Curiosity. It has a robot arm in front like before. But this one has a particular focus, which is to do sampling of the planet. It has a sort of metal test tube type system where we sample the planet. We can take loose soil, but we really take rock cores a lot and put them into these sealed metal tubes. They have a hermetic sealing system that we have on board. And the idea is that a future mission, one that we're just starting right now, is going to pick those up, launch them into Mars orbit, and bring them back to Earth. And we're going to have a sample return of Mars in the next decade. We're aiming for the next decade, by 2030. When I showed the Galileo mission before, orbiting Jupiter, I mentioned that we did flybys of other moons, and Jupiter has a lot of moons. It has 4 big ones and lots of small ones. But one moon in particular stands out for us, and that's called Europa. If any of you are science fiction fans, you might have even read books where Europa gets featured. And that's because we have been looking for signs of life in our solar system. And that's because it's such a pivotal question. If we find something, not little green men, but let's say microbes, it's, you know, we've already figured out there's no little green men in the solar system. We figured that out a long time ago. But honestly, when this business started, they weren't sure, right, in the 60s. But there's nothing like that. But what if there's microbes? What if there's even a plant or something like that, or a type of algae or whatever? If we find something like that, that would be monumental. That would say something fundamental about life itself. If we don't find it, that's also pretty monumental. So the search for life is a really compelling scientific exploration, and Europa happens to be the next place we want to check. We've been checking at Mars a lot. We haven't found it yet. We have found signs that might have shown there was life, but nothing conclusive. And a key part of the life exploration is water. Because as our understanding of life is, we find life in all sorts of weird places on the Earth, including places without sunlight, places without oxygen, at the bottom of the ocean volcanic vents, deep in the it's the magma of the Earth, actually. It's very, very strange places. But at a molecular level, we do find there's water in all those places. So we think that's a good thing to follow. Follow the water has been our theme for a long time. And Europa is a planet that has a lot of water. It has a lot of water under a giant ice crust. So there's a giant ice crust, and below that, based on radar measurements of sloshing that we can find, we think there's actually liquid water underneath there. You know, these other planets and moons get hot as you go down, just like the core of Earth is hot. The core of these moons can be warm. And after that layer of ice, like kilometers thick ice, there is liquid water. And so we think that could be the next place. And Europa Clipper is going to go check Europa out in particular with various other instruments. It won't land, but you better believe that's the next thing we want to do, is we want to land on Europa and figure out what we can learn by being there in person. We also have a mission called Psyche, and it's going to an asteroid named Psyche. Those things are named. The asteroid of Psyche is unique in that mostly asteroids are like mini moons, and they're, crumbly. If they look like our moon, right, with that crumbly sort of rock and dust that you see. But Psyche is different. Psyche is an entirely metal object floating there. So we don't know exactly why that is. There are some other ones, but Psyche is certainly the only one that's big. I think maybe it was a core of another larger asteroid that crashed into another and obliterated everything but this metal core is all that remains. So it's a unique object in the solar system we want to go visit. And getting back to Mars, back to the Perseverance mission, you may have heard that we actually have a little mini helicopter on board this time. For launch, it lives underneath the rover, but we're going to unfold and deploy it, back away, and then it is completely separate. It's got a little solar panel on top. It's got counter-rotating propellers. It's got a camera, and we're going to We practiced in Mars pressure, which is almost no, it's like 1% of the pressure of atmosphere that we have on Earth. It's not much air to fly in at all. But we practiced in test chambers that mimic that. And we can fly it on Earth, and we think we're going to fly it on Mars too. And then I'm going to close here by saying we use JPL's talents in other surprising ways. I don't know if anyone saw this in the news, but you might be able to figure out by the people standing in masks that this has something to do with COVID. And sure enough, when the coronavirus pandemic started, we had a few innovative JPLers who said, I think we can do something. I think we can put our technical talents to work and do something to help this. It's not space, but we're smart people and we can probably figure something out. And there's a bunch of people here. I'm gonna single out this one guy in the middle here with the colorful mask, David Van Buren. He was the one in my division who came to me and said, Mark, I think I can put a team together and we can do something. They didn't even know what they were gonna do in the beginning, but he had some contacts, just like everyone knows a doctor or a policeman or something like that. And he knew a doctor at a local Pasadena hospital, and they started innovating and figuring it out. And pretty soon they figured out the thing we could do is design a ventilator that is easy to build. That is not the be all and end all, not the deluxe ventilators that are in ICUs, but a ventilator that could be built cheaper and faster than most normal ventilators. And then we're going to give the design of that to the world freely. And so they worked super rapidly and they put together this vital ventilator. A representative from JPL came and had a press conference with the president showing that. And we're not a factory, we're not a production facility, we're not building 1 million ventilators, but we designed it rapidly and tested it and then made the designs freely available. And then people in Brazil and other places, they have been downloading the design of that and going off and building more ventilators themselves. So that's an overview of JPL and a little bit of my part in that too. And thank you for having me. And I'd be happy to have any questions if there's time. Jerry has a question, but I guess.
Yeah, Mark, one question I have on all these vehicles or robots, how has the life expectancy of them been, considering what you expected when they were built and sent off to wherever?
Yeah, that's a good question. It has, for the most part, it's been way beyond the expected or rated life. So much so that that's kind of something that we are known for. So Voyager wasn't designed to go into interstellar space, and the Opportunity rover wasn't designed to last 11 years. It was designed to last, I think it was, what did we do at the beginning? It was 90 days or 6 months or something like that. And it just went and went and went. And that's mostly been true. Of course, we have had some failures. I didn't put those on the slideshow, but we have had some failures. And we have had, to get to your question here, once in a while, something that lasts just like your car battery or something like that, exactly as long as it was supposed to last, and then it died. And the funny thing is that NASA has been quite disappointed with us when that happened. And we thought, well, wait a minute, that's actually what it was supposed to do. You're just so used to our things lasting 10 times longer that when something actually only lasted as long as the life expectancy, that was a little bit of a disappointment. But I think it's fair to say that JPL has a reputation for things lasting longer. We're certainly a high quality engineering organization. To be honest, we're sometimes an expensive engineering organization, and those things go hand in hand. It's like, a Swiss watch sort of thing, right? That's the mentality of the people who are trying to design it to go above and beyond. I see Mike Hodge waving a hand.
Hi there, Mark. My question for you has to do with what JPL is doing to foster the STEM programs and the robotics things that are going on in schools.
Well, that's a good question. We do have, I think we have two things. We have both formal and informal. Informally, a lot of JPLers like to do kind of like what I'm doing today, and they give talks to other places. They work with their schools largely in Southern California, ones we can get to. We're part of FIRST robotics competitions, things like that. And they reach out in that way. Oftentimes, I mean, when my kids were in elementary school, I gave a talk at the elementary school, you know, and some things like that. And we're encouraged to go to schools that don't happen to be the ones that our own kids go to. That's the informal. More formally, I think our relationships are mostly at the university level. I'm less familiar with any formal ones that occur at you know, high school or below, but we definitely have a lot of connection to a lot of universities, and in this case, not just local. We have you know, both internships and work that takes places at universities and different engineering programs. It's kind of unbounded and unconstrained. It can be anything, but the most formal programs, the most work we're doing are with HBCUs and MSIs. That's historically Black colleges, universities, and minority serving institutions, right? So we're trying to do our part to make a strong effort for diversity and inclusion and work with university programs that are aimed at that. And that itself is a wide net. We can go to lots of places. I don't know all of them off the top of my head, but I can say, like, for instance, one that I happen to know fairly well, and it's been very active for me in some of those Mars programs, has been UC Merced. We had, in this case, someone who was a graduate of UC Merced, and he was a specialist in tribology, which is lubrication and oils and greases and things like that. He knew of a lab that he'd worked with. UC Merced, you might know, is the newest UC campus, and it's just sort of, it's fascinating to go to UC Merced. Every time you go, they've got a new building because they're brand new. And so UC Merced is a minority serving institution. So we are able to do continued work with them and other universities too, Arizona, Stanford, universities back east, all those sorts of things. Thanks for the question.
Mark, I have a question from the chat area, and it's
Thanks.
John Sandhar, and he asks, the mission control and scientists that interact with the robotic rovers, do they adjust their work and sleep schedules to align with the Martian day?
Yes, the answer is yes and no. And it's kind of unique to Mars because when we're flying Voyager or something, of course, there's no night or day. And so we just have to work, we have to design shifts to deal with those spacecraft. But when we're on the surface of a planet, there is a night and day. We do a lot more during the day than we do at night, and we have to design accordingly. And Mars has a day that I think it's 26 hours. I can't remember. It's similar to, but not quite the same as Earth. And so you think you're just a little bit off, but once you're on the team for 2 weeks, it's completely flip-flopped, and their day is our night and vice versa. So they do often do a planned, let's operate on Mars time, even though, of course, we're living here in Earth time. And they even have special watches that have 26-hour days on them, and they work to Mars time. Now they typically do that in the beginning, when for the first, say, 3 months or something, and then I think they're going to do that again on Perseverance, where they want to be on Mars time to get the maximum out of the Mars day, no matter how inconvenient it is for the Earth people and their Earth homes and lives and kids and everything else. But they sync up with Mars for like the first 3 months or something. And then they will shift to an adapted schedule after that. There's another question, and I see Mark Chandler had raised it, and I see it in the chat box. I'll just take that. Does JPL have a relationship with SpaceX? Good question, because SpaceX is so much in the news today. I don't know if any of you saw their amazing test launch they did yesterday with a Starship vehicle and its belly flop sort of working. Although they didn't quite stick the landing, it's amazing. And SpaceX is down the street from us. They're in Southern California. There are a few places too, but they're primarily in Southern California. And we have this relationship with SpaceX. They are mostly in the rocket business right now. And JPL, despite starting in the rocket business in those old black and white photos, we're in the space probe business. So we launch a number of missions on Falcon rockets, SpaceX rockets, and I know that will continue. We have not yet done anything that I would consider a partnership, an express partnership, although we've talked with each other about that. And nor have they started basically eating our lunch yet and doing space probes, but something we talk about and wonder and keep looking in the rearview mirror. I think their interest in ours are a little different, that they're part of, even if they get into the moon-based business, it will still be a little different than JPL. But we are super excited about their rocket fleet that they've already got, and the new ones that not only them, but Blue Origin is another one that we're looking at a lot. Be able to launch cheaper and or bigger stuff.
Thank you.
Yes.
As a person who sends probes to other planets and solar systems, do you put any credence in our UFO phenomenons? Are we being probed?
Yeah, it's a good question. It's funny, as a kid, I was so fascinated by that stuff, right? I would go to the library and check out books and watch Project Blue Book when it was on TV, and those Close Encounters of the Third Kind. I don't believe in that stuff any longer. I don't, the face of Mars and things like that. But, people do. And we occasionally, I've been at JPL long enough to see people carrying interesting signs out front of our guard shack, interested in what we're covering up, what we know that we're not telling people. But that's not how it works. I mentioned like that vital ventilator. We're in the public information business for space exploration. So either people believe it or they don't. I don't know, but that's what we're doing. Jerry, I guess. I can see.
Yeah,
not all
question. I know, there's it depends on how far the probe is away from, JPL, but is being able to getting the reaction back, and it's just the timing of all that's got to be very, very difficult and tough on patients.
That it is tricky, and so the radio transit time to Mars is basically it's minutes, is in tens of minutes or 8 minutes, 12 minutes, 30 minutes, depending on where the two planets are with each other. And so we have to. Well, as we say, we don't joystick our rovers. You can't drive them like that with really a joystick. You give them commands to go to this object, and it knows it can drive to that point on its own. But what we would like to do is get our probes even smarter and smarter, so that we can even tell them. I mean, we can't yet tell one of our rovers, go find an interesting rock and drill it and tell me when you're done with the whole thing. It doesn't work that way. We could do that stuff with systems on the ground, but we don't have the reliability yet to do that at things in space, but we'd like to get to there someday. And then for Voyager out there, it takes hours to get a message. Voyager is, not as capable as a Mars rover spacecraft, but still the things it does, the nature of the communication is that, we send the message and, a day later you find out that it did this or that. So that's tricky. And something I glossed over about JPL is I should have put in, this giant radar, communication dishes that we have, 3 points in the world, the Deep Space Network. We have dishes in California and in Spain and Australia, so that no matter where the Earth is turned, we have some giant dish pointed out into space, and it can talk to Voyager or what have you. And so that responsibility is also JPL's. That it's basically the communication system, the internet of the solar system belongs to JPL right now, or we're responsible for it. There's a question in the chat, says Perseverance is about halfway to Mars. How long does that journey take? It generally takes about 8 months, let's say. There's some variation based on where the planets are, but really we typically launch at a time when they're as close as we can time it. We could take longer trips to Mars, but that's about as short as we can make it, and that's pretty much what we aim for every time, about that 8-month journey. I'm sorry, I missed a couple questions. Linda, why is Europa not considered a planet? You know what? I'm not up to speed on what the definitions of planets versus moons are, but I know that Europa orbits Jupiter. It doesn't orbit the sun, so I think that's the primary definition of why it is a it's a moon. Nishan, Nishan asked two questions. Okay, one is a follow-up on STEM and robotics about mentoring. I think that's something we could follow up afterwards via email, but he also asked, or he or she, I think what protocols are in place to prevent germs or other microscopic life from being transported to Mars and other planets? Super good question. One that's actually in my division as well is planetary protection, we call it. There's an entire group of planetary protection. I have mostly mechanical engineers working with me, but we have a small group, well, between 10 and 20 people actually, of microbiologists. Sometimes they have some other backgrounds too, but they're primarily microbiologists, and their purpose is this. And we've actually been doing this. We kind of winged it when we went to the moon, actually, if you think, because everyone thought there's no way somebody could live on the moon. And we're lucky that was true, because we brought rocks back and we opened up the hatch and all that sort of stuff. But we're being a lot more careful with Mars and places that we think could have that for two reasons. One is we don't want to bring something back to Earth that is hazardous to the Earth. And we also don't want to bring something to Mars that is either hazardous to Mars. I mean, you know the stories on Earth about whether it's cane toads or other invasive plants where we bring something from one place to another and it takes over the place. Well, we don't want to do that on a solar system scale where we screw up another world. And we also don't want to take something to another place where maybe it doesn't screw up the entire other planet, but when we do our own sampling, and we're looking for life, we have to be sure that we don't find something that we brought with us and then get fooled. So we have a lot of work on biological cleanliness and sterilization that uses all sorts of techniques, but largely it uses we bake things in an oven to a temperature that would basically kill things, and we do a lot of alcohol wipe down, and then we do some more exotic things like they do in hospitals actually, where they use vapor of hydrogen peroxide to sterilize things and instruments.
So Mark, I think we have time for one more question.
Okay. One more question. Should I take the one in the
I do have one here is, when is your open house at JPL?
When is the open house at JPL? Right now everything's on hold because of COVID. It has sometimes been in the May timeframe, sometimes been in September. When it happens, maybe I could tell Jerry or something, and he could send the news to everybody, because it's like buying. We joke, it's like getting Beyonce concert tickets, because there is a ticket site. It's free, but you have to be there when they say they're going to be available. Sunday at 10 a.m. is going to be the time when tickets are available for the JPL open house. You have to be on your computer at Sunday at 10 a.m. and hit, the submit or I want a tickets button at 10 a.m. to be able to get time slots. And then they have timed entries, and they have Saturday and Sunday. And the truth is, if you come on Sunday, you don't necessarily have to be that 10 a.m. finger on the button person. There's a little bit more flexibility Sunday morning, but the Saturday ones go really fast. And we have lots of exhibits and things for people to see. All right.
I want to sincerely thank you for coming to this meeting and making your presentation. It was fantastic. And we'd like to send you a little thank you gift. I think it's just a Rotary coffee mug, but we'll also have a children's book that we donate to the library in your name. And make sure you get that information.
Thanks. I really appreciate it. It was great coming to talk with you all. My mom's still in Lodi. I make it to Lodi now and then. Once COVID's behind us, I'll make it more often. And thanks for having me, everyone.
Thank you very much, Mark.
Thank you, Mark. You'll have to come visit the museum.
Yes, I will definitely do that.
We'll set something up when things change. Thank you, Mark.
Very good. Thanks.
Is there anyone here from Elk Grove High School at the robotics team?
Yes, there are
Does Jim Elliott?
there's a couple of students I recognize, Definitely Lana Wong and Afraz and Gurveer are 3 students that I recognized.
It's wonderful. That's glad you could participate.
Good. All right. Bye,
Mark,
everybody.
can you give us your email so that you can share it with Nishan about possible mentoring?
Okay.
Mention.
Yes, that would be great. Thank you.
All right.
Can you put it in the chat
Sure.
or no? It's okay.
I'll work it through the Rotary here. They'll get it back to you.
Yes,
Okay,
we could do
yeah,
that.
that's
We'll
good.
do that.
Thank you.
Okay.
Sounds good. And then Ralph is on the Rotary, so you can get in touch with me through Ralph.
Okay. Very good.
Okay.
Thank you.
Thank you, everybody.
Thank you very much, Mark.
You're muted, Joe. Hey, Joe, you're muted.
Say it again.
Well, we'll Zoom again next week, and that'll be our Christmas program. Stay tuned for more information on that. And until next week, remember, Rotary opens opportunities.
You bet. Thanks, guys. Thanks, Joe.
Bye-bye. Thanks for coming. Have a nice Christmas if we don't see any of you before.
Hey, Jerry, got a question for you. Can you stay on for a sec?
Yes,
Okay,
yes, I'm here.
you're there. Okay. We'll wait until everybody else leaves. It's very secretive.
I wanted to ask him, I've got to ask him, but it looks like they just settled Nepal and, was it Pakistan? Just settled how high Mount Everest is. I guess that's been in question. So I
It's
saw
interesting.
news the other day and they were talking about somehow they got it settled. So I guess, so I was just asking him if he knew how they did that.
Well, yeah, and it'd be great to have him come to the museum whenever we, reopen, but since he's local, that's fantastic. So it was very interesting, a lot of good questions.
Yeah. No, he was local, but he lives down there, but his
Yeah,
mother.
right. But his mom still lives here. He has to come home and visit his mother.
No, exactly. So that's great. Yeah.
Okay, I'll give you a call in a sec, Jerry.
Okay.
I'll call your cell. Okay, bye, guys. See you next
All right,
week.
thanks. Thanks, Sherry. Joe, thanks for setting it up. Good, great.
Hey, Sherry. Sherry, can you hear me? Yep.
Yes, I can hear you.
Okay, so for next week's cabinet meeting, my name is down for the